I don't think people understand just how fascinating concrete is. It's one of those things we see every single day but rarely stop to think about. Concrete is everywhere, quietly shaping the world around us, yet most of us never consider what goes into making it, or how it transforms from a pile of powder and rocks into the solid foundations beneath our feet. Today, let's dive into its secret life and explore the journey from its raw ingredients to the final construction marvels we see around us every day. We'll uncover the science, the history, and the incredible versatility that makes concrete the backbone of modern civilization. Concrete is everywhere. From the roads we drive on to the towering skyscrapers that define our city skylines, it's the backbone of modern construction. But what exactly is it? What makes this material so indispensable? If you look around, you'll notice that almost every major structure, bridges, tunnels, dams, even the floors and walls of your home, relies on concrete in some way. It's not just a building material, it's the silent partner in our daily lives, supporting everything from the smallest garden path to the tallest skyscraper. But, how did we get here? Why did concrete become the material of choice for so many of humanity's greatest achievements? Let's break it down. First, you need 4 main ingredients: cement, water, sand, and gravel. Think of cement as the glue. When mixed with water, it creates a paste that binds everything together. This paste is the heart of concrete, initiating the chemical reactions that lead to its hardening. The sand and gravel, known as aggregates, provide the bulk and strength. But did you know that the concept of concrete dates back thousands of years? The ancient Romans were masters of concrete, using volcanic ash mixed with lime and water to build structures that have lasted for millennia. Their secret recipe allowed them to create massive domes and aqueducts, some of which still stand today. Modern concrete has evolved, but the basic principles remain the same. A careful balance of ingredients mixed to perfection and poured into place to create something strong and enduring. Sand and gravel, often referred to as aggregates, are the fillers that give concrete its strength and bulk. The proportions of these ingredients can vary, leading to different types of concrete with unique properties. For example, using more gravel can make the concrete stronger, while more sand can make it smoother and easier to work with. There are different types of concrete too, each tailored for specific uses. Regular concrete is used for sidewalks and patios, but that's just the beginning. The science of mixing concrete is a delicate dance. Too much water, and the concrete becomes weak and prone to cracking. Too little, and it won't flow into the molds properly. Even the temperature and humidity can affect how concrete sets and hardens. That's why skilled workers, known as concrete finishers, are so important on any construction site. They know how to read the mix, adjust the ingredients, and ensure that every batch is just right for the job at hand. Regular concrete is used for sidewalks and patios. It's the most common type and is perfect for everyday applications where high strength isn't a critical factor. But when we need more robust structures, we turn to other types. For example, think about the concrete used in your driveway or a parking garage. These areas need to withstand the weight of vehicles, so the mix is adjusted to be stronger and more durable. In some cases, additives are included to help the concrete set faster, resist freezing temperatures, or even change color for decorative purposes. The versatility of concrete is truly remarkable. It's like a blank canvas that can be customized for almost any need. Reinforced concrete, with steel bars inside, is used for bridges and buildings. The steel bars, or rebar, provide additional tensile strength, allowing the concrete to withstand greater forces without cracking. This combination of materials makes reinforced concrete incredibly versatile and strong. Without reinforcement, concrete is strong in compression but weak in tension. It can easily crack under bending or stretching forces. By embedding steel bars within the concrete, engineers create a composite material that can handle both compression and tension, making it ideal for everything from high-rise buildings to massive bridges. Reinforced concrete has revolutionized architecture, allowing us to build taller, longer, and more complex structures than ever before. It's the reason we have soaring skyscrapers, sweeping overpasses, and earthquake-resistant buildings in cities around the world. Then there's lightweight concrete, perfect for insulation and roofs. This type of concrete uses lighter aggregates, such as expanded clay or shale, to reduce its overall weight. Despite being lighter, it still offers good strength and is excellent for reducing the load on structures. lightweight concrete is especially useful in high-rise buildings, where every kilogram saved can make a big difference in the overall design and safety of the structure. It's also used in precast panels, soundproofing walls, and even floating docks. The ability to tailor concrete's weight and properties opens up a world of possibilities for architects and engineers, allowing them to push the boundaries of design while keeping buildings safe and efficient. The magic happens when you mix these ingredients. They form a slurry that's poured into molds. It hardens over time, thanks to a process called hydration. During hydration, the cement reacts with water, forming crystals that interlock and give concrete its solid structure. This process is both simple and incredibly complex. On a microscopic level, tiny crystals grow and weave together, locking the sand and gravel in place. A fun fact, concrete gets stronger as it ages. So, that sidewalk you walk on? It's getting tougher year by year. In fact, concrete can continue to gain strength for decades, as long as there's moisture available for the chemical reactions to continue. That's why some of the oldest concrete structures in the world are still standing strong after thousands of years. The curing process is critical. If concrete dries out too quickly, it can crack and lose strength. That's why you'll often see workers spraying water on new concrete, or covering it with plastic sheets to keep it moist during the first few days. Concrete might seem simple, but it's a true workhorse in construction. Its ability to be molded into any shape, combined with its strength and durability, makes it an essential material in building our world. Now you know the secret life of concrete. Pretty cool, right? The next time you walk on a sidewalk or drive on a road, take a moment to appreciate the incredible journey of concrete, from its humble beginnings to the sturdy structures that support our daily lives. But the story doesn't end there. Concrete is constantly evolving. Researchers are developing new types of concrete that can heal their own cracks, absorb pollution from the air, or even generate electricity. Some modern concretes use recycled materials like crushed glass or old concrete to reduce their environmental impact. Others are designed to be ultra-high performance, with strength and durability far beyond anything the Romans could have imagined. The future of concrete is bright, and it's likely to play an even bigger role in the sustainable cities of tomorrow. So, the next time you see a construction site, remember, you're witnessing a process that's both ancient and cutting-edge, simple and sophisticated, humble and heroic. Concrete truly is the unsung hero of our built environment, and its story is far from over.